Hey y'all, in this video I'm going to work through the calculator inactive section of the 8th grade math release EOG in North Carolina. Before I would start the EOG, one thing that I would do on my blank piece of paper is I would list out my perfect squares 1 through 20. So like 3 squared is 3 times 3, that's 9. 4 squared is 4 times 4, that's 16, and so on until I get to 20 squared. So I would have those memorized before the test, and you're going to see in this video where that is going to show up handy. All right, the first released question with no calculator is talking about what graph shows a negative association. And so my strategy here is you need to know what way slopes go. So my friend, Mr. Slopeface, there's a positive slope, negative slope. Vertical lines have undefined slope, so his nose is a U, and horizontal lines have 0 slope, so that's the mouth. So this is going to be super helpful. We want negative. Negative is this right eyeball. So the first one's closer to a 0 slope, not that. B is closer to, is a positive slope, so it's not B. C is a negative slope, and D is positive again, and so C is the only one showing a negative slope. Number 2, what is a linear function of x? Something that you need to study and you just have to know for the calculator inactive section. I see one almost every year. There is these rules. So linear function can't, or I'll say x can't have an exponent. X can't be an exponent, and I'm going to abbreviate. X can't be in the denominator of a fraction, and X can't be in a root, right? A square root, usually in 8th grade. So when I look at this, I'm like, okay, well, X can't have an exponent, not A. X can't be an exponent, not B. X can't be in a root, not C. Okay, then that lends me to be like, okay, the linear one has to be D, but also we can write this in slope-intercept form. 8 over 4 is just 2x, and 2 over 4 is 1/2. And so the slope here would be 2, and the y-intercept would be 1/2. This is a slope-intercept form. It is linear. All right, number 3, a charity event raised 4 times 10 to the $6 for research. This amount was 5 times as much money as the event raised the previous year. That sentence is crucial. This amount was 5 times as much as the previous. I'm going to write it out like this. 5 times, use my pen marks, the previous is equal to the new one. And we want the previous. It says, how much money did they raise the previous year? Well, if it was 5 times the previous, I'm just going to divide by 5. All right, now when we divide in scientific notation, one strategy is just to expand 4 times 10 to the 6th. That might be what I do because I always forget the shortcut rules. Actually, that is what I'm going to do because 4 cannot be divided by 5. If 4 could be divided by 5, I wouldn't expand, but I'm going to expand. 4 times 10 to the 6th goes like this. 4 with 1, 2, 3, 4, 5, 6 zeros. I moved the decimal place 6 times. So I end up with 6 zeros going that way. And I'm going to put a 5 out here. 5 goes into 40 8 times. 5 times 8 is 40. Subtract 40, you get 0. And then guess what? After that 40 right here, I'm going to bring down a 0. It goes in 0 times. Bring down a 0. It goes in 0 times. Bring down a 0. It goes in 0 times. Bring down a 0. It goes in 0 times. Bring down another 0. It goes in 0 times. So I have 8 with 5 zeros. I'm going to move it back. 1, 2, 3, 4, 5. I get 8 times 10 to the 5th, which is A. Now let me talk you through some. These are hard questions. I would say scientific notation questions are some of the hardest on the 8th grade math EOG. Use your test-taking strategies. If we know that 4 times 10 to the 6th was 5 times the previous, that means the previous had to be smaller. So I can eliminate the ones that are bigger, right? 10 to the 7th is going to be bigger than something that was 10 to the 6th, so cross out D. 8 times 10 to the 6th is bigger than 4 times 10 to the 6th, so cross out C. And now you would have just been taking a 50-50 guess. Also, with your strategies here is you would see that I I think you could maybe think about that 2 times 10 to the 6 might have been 2 times. So just think about those test-taking strategies to make some good eliminations. All right, when we're talking about functions and we're looking at a graph, we're seeing if it passes the vertical line test. I'm just going to start doing the vertical line test. All right, it doesn't cross more than once. That means it is a function, so I'm going to eliminate A. Any parabola, that's what this is called. You'll learn about it more in 9th grade. Any upside down or upside right U-shape is always a function. B, when I draw my vertical line, it crosses twice. This is not a function. B is the answer, but let's double check C and D. C passes the vertical line test. There's no place I could draw a line where it would cross more than once. And D also passes the vertical line test. There's no place it crosses more than once. All upward shaped V's and downward facing V's all pass the vertical line test. They're all functions. All right, number 5. Something you have to know about irrational numbers means they can't be fractions. All right, and it's also most likely a square root you don't know is going to be the answer here. But let's look at A. A is division. Division is a fraction. That's just another way of writing a fraction. So that's rational. 1/3 times 7/5 is multiply across the top. 7 across the top, 15, that's a fraction. Well, it's supposed to not be a fraction, so it's not that one. All right, these questions typically show up to test your knowledge of if irrational, what type of square root it is. I know the square root of 9, right? If I had made that list of squares earlier, I would have been like, okay, 3 squares, 3 times 3 is 9. So this is really just -3. When you get to 20, 4 squared is 16, 5 squared is 25. Since there's not a whole number in between 4 and 5, that's my clue that that's the answer. All right, another question that's going to test your perfect squares. We have a square with an area. Area is length times width. And so that's just side by side. We know square sides are the same. And so if area is just length times width, that's just side times side, side squared. This the same number has to be on both sides in order for it to be a square. So I'm like, okay, well, I'm here on my list. Let's try 6 squared. 6 times 6 is 36. And so then that would be 6 and 6. 144, let's say you had studied those perfect squares 1 through 20, like I mentioned at the beginning of the video. You would have listed out 10 squared is 10 times 10, that's 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is 144. Now, let's say you forgot. When you're making your list, you can do an old school multiplication problem or whatever method you learned in elementary school. You can use your old school skills. But if you have them memorized, it just makes it easier. I bet 1 through 20 is all you really need. So 12 and 12, it says how much greater is the side length of the second square than the first square. So I'm going to say 12 take away 6. That means it is 6 bigger because it says how much greater. If the question had said how many times greater, the answer would be 2 because 6 times 2 is 12. But it says how much greater, so we're just subtracting. Number 7. This is, my opinion, the hardest question on this section of the 8th grade. It might be the hardest one, in my opinion, on the whole release form itself. You're given 2 triangles. You're given the second and the third transformation, and you're asked, what was the first one? So the options are reflections and rotations in this question. So we know it flipped or it turned, right? That's what a reflection and a rotation is. I like to figure out what side matches up with what other side. Well, if you look at the hypotenuse, that has to be match up to the hypotenuse. So G and E have to match up with M and T, but I just don't know what order yet. All right, so then let me look at the sides. This, if you notice, this x-axis is counting by 2s, so really halfway is counting by 1s, if that makes sense. So like if I were to list out H is in the middle between -2 and -4, which means it's at -3, and then it's at 2. And then I have E, which is also at -3, and it's down at -2. And I have G is at -6, 2, okay? So I want to think about the lengths of these sides. So H to G is going from -3 to -6, so it's 3 long. Then H to E is going from positive 2 to negative 2, so it's 4 long. So I looked at the second transformation. I know that it's flipping or turning, but I'm like, well, what else happened? It was dilated by 2. That means it was doubled. All right. So I'm basically going to see which of these sides is double those original sides. So P to M goes from, right, this is really 7 in the middle. So 7 and 1, because that's in between 0 and 2. This one's at 1. So 1 to 7 is 6 long. And if I look at P to T, that's at 3. And 3 is going to 11. 3 to 11 is 8. And so we know that they're supposed to double. And so if I highlight them, my pink side matches up with 6 because 3 times 2 is 6. And my green one right here, my 4, is going to line up with this 8. And so when I see this, I can tell it didn't just flip. Because if it had flipped, that green side, like if it had flipped over the y-axis, which kind of looks like what it did, it would be, the green side would be closer to the y-axis than it is. But that means it turned. It's turned around. And the third transformation just says it went right and up. Well, we can see it went right and up. So we're like, okay, well, now we know it didn't flip. It turned. And so I'm in between A and B. No, sorry, I eliminated the wrong ones. I'm in between C and D. I know it turned. That means it's a rotation. Now, 90 degrees clockwise would land, you would go 1 over, and you would land here. And that's the answer. And I know that's the answer because I know that if let's pick a point to look at. I'm going to look at H. H is between pink and green, which means it maps up to P. And if I had gone 1 that direction, it matches up with P. And so then that's my answer. And again, this is, like I said, you got to know a lot about transformations, but you can also make educated guesses, like knowing the difference between a flip and a turn and finding those matching corresponding sides is what we call them. So C is the correct answer here. All right, number 8, Mr. Jones is a driver's education instructor. He compared the number of times blah, blah, blah. I'm reading too fast. He compared the number of times 8 students attended driving practice and their scores, Y, on the driving exam. Okay, so he's like, all right, how many times did this student come to driving practice, and then what was their written exam score in driver's ed? Then he creates an equation to model the data. It says, what is the meaning of the y-intercept? What you have to know about this question is that the equation of a line goes y equals mx plus b, and that m is the slope, and that b is the y-intercept. Okay? So B is the y-intercept, that's 60. So I already know the y-intercept is 60. All right, so I'm going to eliminate A and D because it has to have 60 in it. The other thing you need to know about y-intercepts is that that's the starting point. So let's read these questions. A student's exam score should increase by 60 points each time they go to driving practice. Or C, a student should expect to get an exam score of 60 if they do not attend driving practice. Well, driving practice is X. It says here the number of times X. That means this is dealing with how many times they go to driving practice. And so if X is 0, right, this would be 5 times 0 plus 60. That gives us 60. So it's what they should expect to get without any practice. It's the starting point. And then it goes up 5 per time they go to the driving practice. All right, number 9, knowing if a set of points is a function, you look at the x values, the first number in the parentheses, and you want to see if they repeat or not. All right, so I'm going to look at my x values. I got a -2, a 0, a -2. Uh-oh. As soon as I see these repeat right here, -2, 3, and -2, 0, they repeat with a different y, not a function. All right, let's do this again. I've got 3, 3, 3, 3. Whoops. They all have different y values. Not a function. One thing to be careful of in these types of questions is sometimes they'll ask which one is a function and sometimes they'll ask which one's not a function. So don't get the question wrong because you went too fast. All right, let's look at this one. We have 3, 0, 4, 3. Uh-oh, we got 3 repeating twice here and here. 1 with the -2, 1 with the +2. That's not allowed. X cannot have a different Y. Can only have the same Y. All right, let's look at the last one just to make sure. 2, 1, -2, -1. No X repeats at all. This is the answer. Take these slow because, in my opinion, these are more of like a low difficulty level question. As long as you know X can't repeat, you can get the answer, but you can mess that up by not reading the question correctly or going too fast. Number 10, as someone like me, am going fast again so I can shorten the length of this video. The equation right here can be used to estimate the number of cars in a parking lot X minutes after the end of the concert. What is the meaning of the slope of the linear model? All right, I'm going to rearrange this equation. This is the same thing as y equals -30x. I just move it with its sign in the front. Plus, I put a plus sign because it was positive 1,500. We know slope is the thing that goes with x, okay? So it says, what is the meaning of the slope? Well, I already know I need 30 of my answer choice. So now I'm down to a 50-50 chance. Eliminate those 1500s because the slope is 30. All right, so the answer choices are 30 cars leave the parking lot every minute after the concert ends, or 30 cars will be there when the concert ends. And I'm going to go back and reread the question. The equation can be used to estimate the number of cars in a parking lot X minutes after the end. So since it's -30, that means it's changing by 30 and it's going down by 30. And so the rate of change is 30, so that means 30 leave every minute. Slope is rate of change. Right. 11. I don't know what they're getting at here besides just seeing if you can do old school math and knowing what exponents do. And I guess this is exponent rules, but it's a doozy. All right, so you need to know that that exponent on the outside of the parentheses goes to the numerator and the denominator. And then the same thing here. This would be 16 to the second over 25 to the second. And then you just need to evaluate. Now, there is some cross-reducing allowed here, but I'm just going to straight up do the problem. Actually, yeah, I'm going to straight up do it to the biggest extent, because not everybody knows how to cross-reduce, especially with exponents. 5 to the third is 5 times 5 times 5. Well, 5 times 5 is 25. And 25 times 5 is 125. All right, so now I have 125 times, or over. 8 to the third is 8 times 8, which is 64, times another 8. All right, so you know what? You can do this old school, and if someone needs me to make a video of that way, I can do it. But I'm going to cross-reduce because it does seem better. All right, 5 goes into 25. 5 times 5 is 25, right? 5 squared is 25. So if I rewrite this like this, 5 squared times 5, that's 5 to the third still. I just kept it that way. Over, I'm going to rewrite this as, well, I know 16 could be 4 times 4. Could break it into times 2s. I know 8 is 2 times 2 times 2. But let's just do one step at a time. I'm going to leave the 8 alone. I'm thinking this through. Sorry, guys. I've never worked this one out before. I know 16 can be broken into 2s and 4s. All right, so I've got 16 squared over. I've got 25 squared. So that's 25 times 25. Well, look here. This 5 squared is 25. If you're multiplying across fractions and there's something on the top and the bottom, you can cross it out. So 5 squared is 25. I can get rid of a 25. All right, now I can also get rid of 5 goes into itself once and into 25 5 times. All right, so we're done there. Let's now deal with these 16 and 8. I can't use 4 because, so let's kind of write it like this. I've got a 1 on the top and an 8 over 3 times a 16 squared over a 5 is where I'm at now. Don't know what just happened. All right, now I want to rewrite 8 and 16 where they're things that are reducible. I can't use 4 because 4 times 4 is 16. Although 4 times 2 is 8, you can't break down powers like that. You need the same number. So I'm going to look at 2s. 2 times 2 is 4. 2 to the third then is one more 2, right, times 2. That's 8. And And so then I know every 2 to the third is 8. But I have 8 to the third. So I'm going to rewrite this like this. I've got 2 to the third times 2 to the third times 2 to the third. Because each of those is an 8, and I had 8 to the third. Times 2 to the fourth is actually 16, because 8 times 2 more is 16. So this is 2 to the fourth times 2 to the fourth, because it's squared. 16 squared, 2 to the fourth times 2 to the fourth, all over 5. All right, now I'm going to rewrite these exponents. So the bottom becomes 2 to the ninth, because 3 plus 3 plus 3. So this really is testing your exponent skills, unless you just hardcore do it out. 2 to the fourth and 2 to the fourth is 2 to the eighth, all over 5. Since I have 8 on the top and 9 on the bottom, I can take 8 from both of them, and that leaves me with a 2, and then the answer is 1/10. So, again, you could go all the way across the top and across the bottom and multiply it out. It would take you a little bit longer. That's a hard question. Number 12, the table defines y as a linear function of x. So we know it's a line. If we know it's linear, then we can just find the slope using any 2 points, and I'm going to do the change in y is, the slope is the change in y over the change in x. The change in y is going up 14, if my math is correct there, and the change in x is going up 4. And so then this is 14 over 4, which reduces, divide the top and bottom by 2, and you would get 7 over 2, and that would be the answer. 7 over 2. In the box, you would be like 7/2. Or 3.5, same thing. I would check this by like checking the bottom one. 21 to 28 is 7. 6 to 8 is 2. And so then that's 7 over 2. And so it skips some spots in the table, but it reduces to 7 over 2. So that's the correct answer. Okay, 13, another hard one. You have to know those perfect squares 1 through 20. Okay, 1 squared, 2 squared, all the way up to 20 squared. Just study them. Flashcards them, whatever you need to do. If you have that list out, then you can look at your list. But I'm just going to start what we did earlier. We did 12 squared, right? We said, okay, 12 squared is 144. 13 squared is 169, and 14 squared is 196. And I have those memorized because these two numbers just flip-flop. That's helpful for me. So we're there. We're done. Wow. I thought I was going to have to keep going. So 172 is between 169 and 196. So I know that it is in between 13 and 14. It says, what's the positive integer closest to it? So I need to ask myself, is 172 closer to 169? Or is it closer to 196? So let's just see how far away it is. 172 is 3 more than 169. And it's like 24 more. 24 under 196. So it's closer to 169, which means it's closer to the square root of 169, which means it's closer to 13, which would go in the box. All right, more exponent rules. This one, the rules here. You add the exponents when you're multiplying with the same base. So I'm going to take 3 squared and 3 to the 5th. That's too messy looking. And I'm going to write this as 3 to the 7th. I just added the 2 and the 5. And I'm going to rewrite it over the third. I always simplify it on the top or bottom if like there's stuff going on in the top or bottom. Now, oopsies, we're dividing. The division rule is subtract. 7 minus 3 is 4. You could also do this from the very beginning. 3 times 3 is 3 squared, right? 3 to the 5th, 1, 2, 3, 4, 5. And on the bottom, you had 3, 1, 2, 3. Cross out top and bottom because multiplying and dividing by 3 cancels. 3 times 3 times 3 times 3 is 3 to the 4th. And then, we're not done. It wants the value. And you're not allowed to answer with exponents. So 3 times 3, this is 9, times another 3 is 27, times another 3, you'll have to work it out, but it's 81. Because 7 times 3 is 21, 20 times 3 is 60, add them together, 81. Okie dokie, number 15, we have a linear function passes through the points shown in the table. What is the y-intercept? Now, they are trying to trick you here because they give you a 0. And one thing you need to know about y-intercepts, it's where x is 0. And I don't have where x is 0 in this table, but we can use the slope and the equation of a line, y equals mx plus b, to find it. All right, so I'm going to find the slope, change in y over change in x. So change in y over change in x. My change in my y's from -10 to -4, it went up 6. Now, if you don't like negatives, go down here and do it this way, right? That's 6. This is 6. And then when I go here, this went down 3. Let's see if that happened here. Yep, that also went down 3. So my change in x is -3. 6 divided by -3 is -2. That's my slope. Okay, we need b. We need the y-intercept. Now, this one's not nice because, like, if you could have just kept going down by, like, -3s, that would have given us, like, what, -4. But then you're never going to get to 0 without a decimal. So I'm going to plug in a point. I just always use the top. You know what? I'm not going to use the top point. I'm going to use whatever point looks easiest. Points with zeros in them are easiest. Okay, so then I know my y is 0 and my x is 10. I'm just taking these. I'm going to highlight this green. The 10 is green now. That's the x, see, because it was the x value. And I'll use pink here. The 0 was y. And I put that where y was. All right, so now I'm going to simplify. -2 times 10 is -20. And I need to get b alone, so I'm just going to add the 20 over. And we get b is 20. And that is the y-intercept because that is where x is 0. Okie dokie. That's it. All right, I will link the video for the calculator active section below. If you ever have a question about a specific math question, if you leave me a comment or email me, I will make it and get it back to you. I hope you have a great summer, great end of the year, and that you do really well on your 8th grade math EOG. Have a great day.